Greetings everyone. It's an honor for me to present my research work with all the esteemed researchers and audience in the panel. My name is Aman Pathak, and I'm from India. I've just finished my undergraduate degree in computer science and engineering, and I'm an aspiring data scientist. And to explore more about the field of natural language, I'll begin my master degree this fall. I'm a total beginner in the field of research, and this is my first ever presentation in a conference. So, any suggestions and advices are welcome. Without further ado, I'll begin with the presentation. Natural language has witnessed many substantial advancements in the past 3 years. A few language models have achieved nearly human level accuracy on many downstream tasks, such as writing articles, writing novels, and even writing songs. This significant rate of progress can be also comprehended from the need of more rigorous benchmarks like superglue. The two major contributors behind this success are the one that is the transformer, which is the architecture, and the concept of transfer learning. Before the introduction of transformers in the paper Attention is All You Need in 2017, LSTMs were the go-to architecture for building any NLP models. The introduction of the gating mechanism and the attention mechanisms successfully mitigated the vanishing gradient problems and the exploding gradient problems and enhance the performance on longer sequence length. Despite that, its sequential nature inhibited parallelization in the input examples. Transformers embarked a new journey by introducing parallelization, which facilitated encoding of all paths in the input sequence together. The self-attention mechanism is the real deal, which gives the transformer the power to evaluate the relationship among words and put special attentions on the words which are meaningful in the sentence. The first ever implementation or the earliest implementation of the transformer architecture was GPT, which stands for Generative Pre-training Transformer. And when GPT arrived, it outperformed several task-specific state-of-the-art models which were built on LSTM. Because of this, transformer became a conventional a preference of architecture for many upcoming models. The second contributor, that is transfer learning. Sorry. Yeah. Transfer learning is a very popular practice in the field of computer vision. It can be seen as a very standard procedure to begin any computer vision project with the help of transfer learning. So the rise in the adoption of transfer learning in NLP is something which we have seen growingly exponentially in the past 3 years. The concept of transfer learning provides a better initialization point, which helps the model being pre-equipped with fundamental language skills like understanding the semantics, understanding the logical ability, logical relationships among the word. It has been also proved that the moment when transfer learning was used in NLP model, it has it has raised the accuracy levels in many benchmarks, such as on the NLI task and on the QA task. Surprisingly, we have reached at this point that current researches have led to a model such as GPT-3 that do not require a fine tuning, which is the second part of the process in transfer learning, where the model is being fine tuned on the downstream task which we want the model to perform. So surprisingly, we have reached a point where the transfer learning has reached a certain point where models do not need any transfer learning. So this concept and the transformer concept has been the contributor in the rise of transformers. So I'll move on to the literature review and the inferences drawn about the models. The first model we're going to talk about is BERT, which has been released by Google in 2018 October. It marked the very beginning of the pre-trained deep bidirectional model. This is one of the concept in the natural language, uh, field, that has been one of the most influential, because it provided us with a pre-trained deep bidirectional models. Until now, we had models which were concatenating the left and right context in order to gain a better understanding. But this was the first model which had a deep connections between the context. The term bidirectionality emphasizes the bird's ability to infuse the left and right context and generate even more powerful word embeddings. It has been trained on the two pre-training objective functions, which is a mass language model and the next sentence prediction. Apart from that, a BERT has attained new state of the art when it was released on 11 NLP tasks. My inference about a BERT is that the model's training phrase can be optimized a bit further, because the masking strategy used by BERT uses a mask token to indicate the model that, hey, here is the mask token, and you need to figure it out. But in the real world, when coming to the fine tuning stage, and when we are providing the BERT with our data, we rarely find this mask token. So unless and until we have externally created the mask tokens, it becomes a bit a bit of overload. Also one of the optimizations in the bird architecture can be that to have to treat those sentences where there are two mask tokens with relationships. In sentences with more than one mask, the model, it treats them independently, and as a result, it may hurt the prediction in cases of high dependencies between the tokens. To sum it up, BERT establishes a firm foundation for the upcoming language models. The next model is the Transformer XL. The Transformer XL is an advancement to the vanilla transformer, which was introduced in the paper Attention is All You Need in 2017. The original transformer suffered from a phenomenon that was a context fragmentation. The problem of context fragmentation was that it the information flow between the segments of the document was being not captured, because the sentence is exceeding the maximum sequence length, that is the value is 512 tokens in the original transformers, were not being dealt with. So the information flow between segment to segment of the same sentences were broken down, and this hurted the performance. Transformer XL proposed a solution that is segment level recurrence, and which helped in a way by reusing the hidden layer of the previous segment, which established a proper flow of information, thus capturing long-term dependencies in the sentence. To implement the segment level recurrence, Transformer XL also proposed a relative positional encoding scheme, because of this scheme, self-attention layers were able to figure out the relative distance between the tokens and where to attain them. The impacts of this paper was we now had a 1,800 times speed up than the original transformer in terms of the training and the evaluation process. The next paper we'll talk about is ExcelNet. It is a generalized motor regression model that combines the merit of autoregression and the autoencoder models. We Till June 2019, we knew that bidirectional encoders are are ex- naturally perform better in natural language tasks, and therefore to combine the power of two, ExcelNet was proposed. So in order to implement the bidirectionality into an autoregression model, the ExcelNet used a permutation language modeling. It allowed it allowed such orders that required the context from both the left and the right tokens of the predicting a token, therefore equipping ExcelNet with a bidirectional type behavior. Also, ExcelNet's two-stream self-attention architecture produces two kinds of token representation instead of one, which is in the vanilla transformer. The content representation is the same as in the vanilla transformation, that is used when you predict the content for the other token. On the other hand, the novel query representation is used when the token itself is being predicted. This change was proposed in order to introduce the bidirectional behavior, and altogether ExcelNet has been the one of the greatest auto regression model in terms of the original transformer and the transformer Excel. We now move to July 2019, where we have Roberta has a BERT in it, and it optimizes a BERT by providing a set of modifications in the pre-training method. Roberta is also pre-trained on a data set which is larger, 10 times, a larger vocabulary, and on larger mini batch sizes. A few of the modifications which were proposed were also inspired by previous works which have proved to be success, and those previous works were in the neural machine translation. One of the optimizations was to introduce dynamic masking that eliminates the repetition of the same masked sentence in the pre-training. So what was happening in the BERT when we were training the BERT model? The MLM protocol, which is the masked language modeling, was masking the same sentence for every epoch. The MLM protocol was masking the same sentence for the training data, and this actually caused a repetition in the training process, because every sentence, for each sentence, the same word were being masked. So Roberta introduced a dynamic masking strategy which provided a diverse group of sentences for the pre-training model. It also eliminated the next sentence prediction pre-training method, because in the paper we have seen all sorts of modifications which Roberta suggested actually prove that NSP is not required, and the model actually excels BERT and establishes new state-of-the-art results on glue, squad, and other benchmarks. We now move on to Albert. So Albert optimizes BERT with an aim to reduce the number of parameters. It introduced two modifications in BERT, that is factorized embedding parameterization, which focuses on decomposing the word embedding size and the hidden layer size, which ultimately helps in reducing the number of parameters. And also it includes cross-layer parameter sharing. So instead of having different layers of encoders stack onto each other with different parameters, Albert suggests or proposes to have the same identical encoder stack, where let's say there are 12 encoders stacked upon each other. So each and every one will share the parameter. So ultimately, it focuses upon reducing the parameter with also an emphasis on not hurting the performance. Although Albert falls short as compared to BERT large, but it is 18 times smaller, and it also trains 1.7x times faster. Similar to Roberta, Albert also replaces NSP with a sentence order prediction pre-training method in order to increase the difficulty of this task. We'll see later in the comparative analysis why the next sentence prediction has been mostly replaced by all the models after BERT. And as a result, Albert has also established new state-of-the-art results. We next come to the model that is T5, which was being also produced by Google in October 2019. It stands for text-to-text transformer, transfer transformer. It introduced a unified text-to-text framework where every NLP problem, whether it is a regression problem or a classification task, it has to be presented in a text-to-text format. The model is pre-trained on a C4 dataset, which has been which is a very large dataset, and the motivation for a very large dataset of 760 gigabytes was as it was studied by the researchers at T5 that the model tend to underperform when trained on limited size datasets due to the memorization of the repeated examples. T5 has achieved state-of-the-art solutions on Glue and CNN Daily Mail, which is a text abstraction task. So combining all these things, T5 has also been able to have the highest score on the leaderboard right now on STSB, which is a regression task. And yes, we now move on to Pegasus, which is a sequence-to-sequence model that performs abstractive text summarization. This model is perfectly curated for instances where the downstream task is abstractive text summarization. The model is also pre-trained on C4 and huge news dataset, which both contain large volumes of article. The pre-training model is also GSG, that is gap sentence generation, which suggests that masking of important spans of sentences in an article leads to the better performance and leads to a better trained model. A Pegasus, so the way Pegasus is trained is that all the arrows, all the bows and arrows hit towards abstractive text summarization, and the capacity of a Pegasus is it's pretty amazing that it achieves a great performance even on low resources. When we have sentences when we have even 1,000 sentences, Pegasus was able to set state of the art result on 6 different NLP tasks. We now move on to Electra. Electra is loosely inspired by GANs, where it is a two transformer text encoder. One is generator and one is a discriminator. The replace text detection is one of the methods which was introduced in the March 2020, and it has replaced the mask language model in terms as it learns from input tokens from all the input tokens instead of just 15% of them. During pre-training, the generator part performs MLM, followed by replacing the mask token with convincible substitute using the maximum likelihood. The discriminator is the real deal, which then detects whether the token in the modified sentences have been replaced or not. So instead of learning from just the 15% of mask token by MLM, the Electra's discriminator scans through each and every words of the input tokens, and then it applies its learning procedure. Electra is also considered as one of the most balanced model, which balances the power consumption in terms of training and also performing in terms of performance. A 12.5% trained and a 50% trained Electra small efficiently outsmarts a BERT small and GPT. Or we come towards the last model, that is GPT-3, which consists of 175 billion parameters, and it's the largest model till date we have. The model implements a new type of learning, which is a few shot learning. That is, it states that it is capable of performing a novel NLP task. Just by looking at a limited number of examples and instruction, it will be able to implement that. This ability of a few shot learning has been found in humans, where we do not need a large amount of training data, and we can easily recognize uh, an image of zebra by looking just one or two images of zebra. We'll be able to figure out whether this is a horse or this is a zebra. GPT-3 has exceptional skills for text generative tasks because this model has been able to write novels, has been able to write poems and articles as well. We now move on to the comparative analysis. So our first category, our first analysis is based on the autoregression models model design. A transformer Excel outperforms vanilla transformer, and it is because of the segment level recurrence. It is able to capture 450% longer dependencies in the sentences. The ExcelNet enhances the AR model capacity by introducing bidirectionality. Although the method by which the bidirectionality has been introduced is permutation model language modeling. So the cost of a computation is bit more. The model design of GPT-3 is fairly simple. The model GPT-3 simply adopts the design from its predecessor, that is GPT-2, and it just trains the model a bit larger. So as a result, GPT-3 does not add much to the design, and in many cases, and in a few cases, that is on the race H and the race M data set, which is a natural task to figure out answers from a reading comprehension. It has been even proved, to perform worse than it's the first part, that is GPT. So GPT-3 is also uh, a newer model, a huge model, but it underperforms in some cases as well. The second category is about the masking strategy. So in BERT, we saw that the masking strategy is pretty simple and repetitive. The training examples identify the same masked word in each and every epoch. This was changed when Robert introduced the dynamic masking strategy, and it was further improved when Albert and T5 planned to mask spans of word rather than just a single word, because it makes the pre-trained model train better. While Pegasus is a sequence to sequence model and it does not fit into the category of a comparison, I would just like to mention that Pegasus, which is a text to text summarization model, increases the challenge to a whole new different level by masking an entire sentence and training it on them. Among the sequence to sequence model, we compare Transformer, T5, and Pegasus, which all include the decoder and the encoder part of the transformer. We use the CNN daily mail text summarization task, and it can be seen on the figure on the left hand side that the R1, R2, and the RL scores on obtained on the CNN daily mail as is better for Pegasus in each and every sense. There is a reason why it's that, because as mentioned earlier, Pegasus is perfectly curated for text summarization task, and it has also been trained on extra data, which T5 has not been. So as you can see that between T5 and Pegasus, there is marginally a difference between the R2 scores and the R1 score. So it's because of that. We also test the models on the task of machine translation. We see that T5 T5 leads the leaderboard. Although T5 and GPT-3 achieve a significant increase over the vanilla transformer, they are still behind the state-of-the-art solution. There are two reasons for that. Because GPT-3 and T5 are being trained over a large portion of English data, while the state-of-the-art solutions are being trained on a mixture of German, Dutch, and English text data in order for them to learn the translation capabilities. And also, those models have been especially trained on back translation. We move on to the QA benchmarks. Question answer tasks evaluate the logical reasoning abilities of the model. We use the squad dataset, score 2.0. We find that the auto encoder model tend to perform better than auto regression model because of the bidirectional context. And we also notice that ExcelNet, which is an auto regression model, tends to score higher than Roberta. It is because that ExcelNet has been trained on extra data rather than Roberta. Performance on natural language inference task, it evaluates the semantical understanding between the sentences. We use the recognizing textual entailment task, which is a common NLI task in glue and superglue, where the task is that the model should predict if the meaning of one sentence can be inferred from the other. The the evaluation is same as we saw in the earlier slide, that the auto regression task, auto encoder model have been better in terms of the auto regression models. And and let's focus on GPT-3. We know it's a huge model, but it still lacks from ExcelNet, which is a model of the same category, because GPT-3 lacks the semantical understanding of language. We also saw in the earlier part where GPT-3 performs worse than its own predecessor, that is GPT. So yeah, we now move on to analyzing the raising demands of computing power. We all know that in today's standard, the machine learning models are data hungry, and in order to provide them with large data also requires enough computing power to train them. Below uh, below you can see the chart where the total computing power has been marked. We can see that as the models have progressed from BERT to GPT-3, we have seen a raise in the amounts of data, which also translate in the computing power. We have to appreciate, and it's worth noting of Electra, that Electra balances the total power consumption and the model performance as well. We now focus on to the topic of fair models, because we now focus on to the topics of fair models, because the data sets which are now being used by the language models are often compiled from online repositories, such as the Wikipedia, books, the internet, and social media platforms like Reddit. In all of these resources, we can find traces of human stereotypes and biases, such as a male doctor and a female nurse. We tend to find them very easily. Unless and until they are the data before being used to train the model is being filtered, we won't be able to have fair models. We use the Vino gender scheme to have the accuracy scores about how biased are these models. And and we found out BERT and GPT-3 scores are are highly biased because they get only 50, they score an accuracy of 50%. So GPT-3 as is one of the recent model. The low score can be accounted as the training data was not filtered, and the most occupation when the training data was searched were associated with males, male doctors, male pilot, etc. We now move on to the final category, that is we see a trend that the next sentence prediction has been proven to be ineffective. It's because in the training sentence, in the training data, we see that for the NSP, the training data goes like this. The okay, so just coming back, then the next sentence prediction is a binary classification pre-training objective, where the model learns the sentences relationship by predicting if sentence 2 precedes sentence 1, correctly follows sentence 1. The 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 ineffectivity raises from the kind of data used for training and testing. In the training data, sentences in the positive class correctly follow each other, whereas sentences in the negative class are created by concatenating random sentences from two separate documents. Since the probability of mismatching topics in the two documents is relatively higher, predicting negative class becomes much easier. So it may arrive at a situation that the model might excel in the next sentence prediction task without even learning much about this the semantical relationship in the sentence. So as a result, we see that the new generation of models from the BERT, that is Robota, ExcelNet, and Electra, have chose not to include it, and Albert, replacing it with center order prediction, which states which improves the negative class, and the sentences are being taken from the same document where the sentence order has to be predicted. We now arrive to the conclusion. The study or the research spanned across various aspects. We find that transformers have really streamlined the process of developing language models in the past 3 years. The tradition of transfer learning in NLP is new, and it has proven to be great, as it has been producing near human accuracies on different benchmark scores. It is also noteworthy that BERT, because of his contribution of deep bidirectional representation, has established itself as a baseline model. We end the conclusion with putting an emphasis on the prominent limitations, that is the increasing consumption of energy, the presence of stereotype, and the malicious utilization of the language models to produce fake articles, fake news. These are the references of the models which have been discussed. Thank you so much.